Welcome to your Integrated Science Midterm 2023 for Mr. Kim. The question you will be focused on is how have I improved my skills in science this semester? Background. At Hamtramck High School, your science teachers use next generation science standards to guide your learning. By the time you graduate, it will be more important that you know how to make sense of the natural world than simply just memorizing information. This sense-making process is learned through the 8 science and engineering practices described on the second page of this sheet. Improving upon these skills is a sign of progress. So what to do now for your exam? There are 4 steps. Step 1. You must choose 2 of these activities from the list below that had the greatest impact on you. You must then write them in the column of the table below that says activity. It's labeled green. You can choose from cold hands investigation from week 8, heart rate recovery data from week 10, forearm muscle training plan from week 12, stress comic strip from week 17, or the salamander modeling weeks 5, 10, and 15. Or you can choose a different activity, but you must discuss this with Mr. Kim first. Step 2. For each activity, please choose 2 of the SEPs that you recall using for this activity. Remember, those are on the second page. You cannot use the same SEP more than once, so in all, you should have 4 different SEPs, 2 for each activity, and you have 2 activities. You're going to write that in the blue column below. Step 3. Explain exactly what actions you took during that activity to practice these SEPs you chose. Be as specific and cite specific things you said, did, or created if possible. You will be writing that under the orange column, labeled what actions you took. Step 4. Please explain how practicing those SEPs will be useful in your life after graduating from Hamtramck High School, in your college, career, or life. Be as thoughtful and convincing as possible. You will write that under step 4, the pink color in the chart below. You will see the chart over here. So you're going to write your first activity here, your 2 different SEPs that are found down here. You're going to write what actions that you took and how those SEPs will be useful upon graduation. So let's go ahead and really quickly look at those SEPs that you're going to be placing in the blue one. Number 1 is asking questions and defining problems. Science begins with a question about a phenomenon such as why is the sky blue or what causes cancer, and seeks to develop those theories that can provide explanatory answers to such questions. A basic practice of the scientist is establishing what is already known about the phenomenon and determining what questions have yet to be satisfactorily answered. The second SEP is number 2, developing and using models in science. Often this involves the construction and use of a wide variety of models and simulations to help develop explanations about natural phenomena. Models make it possible to go beyond observables and imagine a world that is not yet seen. Models enable predictions of the form of if, then therefore, to be made in order to test any hypothetical explanations. 3. Planning and carrying out investigations. Scientific investigation may be conducted in the field or in the laboratory. A major practice of scientists is planning and carrying out a systematic investigation, which requires the identification of what is to be recorded and, if applicable, what are to be treated as dependent and independent variables, controls of variables. Observation and data collected from such work are used to test existing theories and explanations or to revise and develop new ones. Analyzing and interpreting data. This is number 4. Scientific investigations produce data that it must be analyzed in order to derive meaning. Because data usually does not speak for themselves, scientists use a range of tools, including tabulation, graphical interpretation, visualization, and statistical analysis, to identify the significant features and patterns that you find in the data. Sources of error are identified, and the degree of certainty is also calculated. Modern technology makes the collection of data of large sets much easier, thus providing many secondary sources for analysis. Number 5, using mathematics and computational thinking. In science, mathematics and computation are fundamental tools for representing physical variables and their relationships. They are used for a range of tasks such as constructing simulations, statistically analyzing data, and recognizing, expressing, and applying quantitative relationships. Mathematical and computational approaches enable predictions of the behavior of physical systems along with the testing of such predictions. Number 6, constructing explanations. The goal of science is the construction of theories that can provide explanatory accounts of features of the world. Scientific explanations apply to specific situation or phenomenon. The goal for students is to construct logically coherent explanations of phenomenon that incorporate their current understanding of science or a model that represents it and are consistent with the available evidence. 7, engaging in argument from evidence. In science, reasoning and argument are essential for identifying the strengths and weaknesses of a line of reasoning and for finding the best explanation for a natural phenomenon. Scientists must defend their explanations, gather evidence based on solid foundation of data, examine their own understanding in light of new evidence and comments offered by others, and collaborate with their peers in searching for the best explanations possible. And then finally, your number 8, obtaining, evaluating, and communicating information. Science cannot advance if scientists are unable to communicate their findings clearly and persuasively, or to learn about findings of others. A major practice of science is thus the communication of ideas and resulting of inquiry, orally, in writing with the use of tables, diagrams, graphs, and equations, and by engaging in extended discussions with scientific peers. Science requires the ability to derive meaning from scientific texts, such as papers, the internet, symposia, and lectures, to evaluate the scientific validity of the information thus acquired, and to integrate that information. This ends your midterm.